Yep. Isn't that oddly satisfying? Watching pistons going up and down. You know what is weird? That you can put 4 pistons at the same height. Well, of course, 2 of them are going down, 2 are going up, but at some point they're all at the same height. Too bad these are old pistons, right? Good for Tom though, because he didn't need to spend money on new pistons. Turned out that this block was not worn at all, so we could use the same original pistons actually, with just new rings. The cylinders were not worn at all. But what am I talking about? You haven't seen that yet. In your world, the cylinders are empty. We installed the camshaft and the crankshaft, and that was everything, right? So now let's go back to that point and start assembling further. So let's get crack-a-lacking. All right, so what should we do next? We have multiple options here, but for option 1, which I was thinking of doing, which was installing the pistons and the connecting rods, we need a way to turn the crankshaft, like from here, from the front. For that, I usually put my adapter for the degree wheel, which is made out of a 1/2-inch socket here. So I usually put it here in the front, and with a ratchet, I turn it. Now I can do that when it is pretty smooth, but when we start adding pistons, it's gonna stop turning. Or maybe not, I don't know. Yeah, eventually it's gonna start slipping on me because we don't have the woodroof key here. So we need to put it back, but I removed it for a reason. I removed it because we wanna determine how many shims we're gonna have to put here in the front. To determine that, we need to have the front engine plate and the camshaft retainer, and then we can put also the crankshaft and the camshaft gears in place, and then we need to align them. So just because I removed the woodroof key, that changed the entire order of processes here, but that's okay. We can assemble the front end, why not? Let's do that. Yeah, right. I'm jumping ahead of myself, you're right. Before we install the front engine plate, we need to install the sealing block. Here we need to make sure that the threaded holes are in a good shape. These are notorious for stripping as well because they are pretty shallow. I mean, this one is deep enough, like it has enough depth here. These ones also seem to be pretty deep, but don't forget that here we have the bolt that is holding it down, and this means that only this much threads we can use. So this plus the thickness of the plate in the front is our length of the bolt. But people don't realize that, and sometimes they put long bolt here and they torque them, not realizing that the bolts are bottomed already into the other bolts, and they strip these holes. Same goes for these two. They land right on top of these bolts, and they also need to be pretty short. But sometimes when people have leaks in the front end, they just go and they torque the oil pan cover bolts as much as they can, and they strip these two holes. So because I know that, I checked the threaded holes when I stripped the engine, and they are all in a good shape. However, something else I didn't notice, and I was just cleaning the block here to install it, and I just realized that, I don't know if you see that, but there's quite a big curve here somehow. I don't know why, but look at that. I'm touching here and here, but in the middle I have pretty big gap. So I don't know how that happened. So this is garbage. So now we need a new block. Luckily though, this year at the trials, when my name was drawn during the banquet, when they were giving the door prizes, and when your number is drawn, you go and select a prize from a big selection of prizes. And when my name was drawn, there was not much left at the tables, but I found something interesting. That's what I picked. Compliments of Good Parts Inc. So that's a front ceiling block made out of steel, not aluminum, for Triumph Spitfire, GT6, TR250 and TR6. I never realized that all these engines use the same block. I mean, GT6 TR250 and TR6, yes, but I didn't realize that Spitfire uses the same block. Well, now I know. So we have a brand new baby here, which looks great. All right, so let's install it. We need gaskets here, and we need blocks of wood for here. They used to come with these gasket sets. Well, not anymore. I guess PN ran out of wood. I don't know what's going on. So we have to make our own. Well, at least they still offer these gaskets, which now in this case actually, this complicated shape is not needed anymore because they are matching the old block here, but the new block has a square shape here. I don't know why they made this complicated shape before, but the good parts block has just square area here, which is better because there's more sealing surface, right? Anyways, we're still gonna use this. We're gonna put gasket maker though. Just wanted to show you, and then we have to use these cheese-headed screws. Here I forgot to mention that these screws don't have any lock washers or anything. They just go just a single screw. Now before I tighten them completely, we're gonna tap this block forward in this case, so we can have a flat surface here in the front, because that's where we have a gasket, right? Okay, that's good. Now I'm using this screwdriver, and we're gonna take a 5/16 wrench, and we're gonna boost our screwdriver, right? Not too much, because believe me, I snapped one of these screws before. Like literally the head split in two. And I was like, what the heck? How did I do that? Okay. I think we moved a little. Somehow we moved a little, so I'm gonna tap it back in. Good. Okay, now let's make wooden blocks for here. I used to think that this is some kind of a special wood specifically for gaskets, but the more I looked at it, the more I realized that this is just a simple wood. So now I'm just grabbing a piece of 2x4 or something here, whatever this is, and we're gonna split it. So I'm just gonna smoothen one end, the one that is gonna be at the bottom on the bench grinder, and then we're gonna tap them in. Don't you just love the smell of the burnt wood when you grind it on the bench grinder? I don't know about you, but I love it. I don't know why. I used to have a shop class. We were doing wood turning on a wooden lathe. We were making like a candle chandelier. What are they called? And at the end, when we have the shape ready, we would take copper wire and we would wrap it around in a deep area like that, for example. And as the piece is turning, we pull the wire and it makes a black mark in the groove there. But the smell, it was exactly this smell. I used to love it. Ever since then, I dream about wood lathe. And to be honest, I have one in the basement that was given to me, and I never ever set it up. But I don't have time. That's my problem. I need time. So I'm just gonna put gasket maker all over the place, just so it can soak into the wood. Later, from the oil and heat and all that, the wood will swell and it's gonna seal, apparently. Somebody was asking before, how come you put wood there? Well, what do you think cork is? Cork gaskets. And I'm sure they would have used cork here. Actually, on the TR4 engines, they use cork in this location, but it is hard to put it on. So that's why they switched to something, to a harder wood, so you can actually hammer it in. So now we're just gonna cut the excess. Okay, Perfect. And now we're ready for the front engine plate, finally. Now for here, in the kit, there are two gaskets that are a little bit off one from the other. And so far, I haven't seen an engine that uses the smaller one. I have no idea what this is for. And I think people made different suggestions in previous videos when I mentioned that, but I don't think that we came up with an idea about that. So you can see, if you match the holes in the top, the ones in the bottom don't match. So this gasket I keep usually, and I use it to cut other gaskets when I need to. So this is the correct gasket for here, making sure that all the holes match and everything. So now I can put gasket maker here, 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 and on the back of the engine plate. In case I haven't mentioned it yet, that's what I'm using, Aviation Forma gasket by Permatex, number 58931, my preferred gasket maker. I love it. I even eat it for breakfast. Okay, so the front engine plate is installed, and the retainer for the camshaft as well, and I put few screws that hold the engine plate in place permanently, but I also put some that are temporary. So this one and this one are permanent, and we have to put this one and this one as well. This one is permanent, and these also are holding the engine plate towards the block. So these are all permanent, but here around the edges of the plate there's nothing to hold it in place yet until we put the cover on, and that's gonna happen in days. It's not gonna be today. So that's why I put these screws temporarily so they can press the plate against the block. So now I can also put these two screws because they are outside of the cover. These are the two holes that go into the ceiling block, and they hit those bolts that go from the bottom up now that we flip the engine around. So they are pretty shallow. That's how deep they can be. That's why we're going to use these. We have just enough room there. And of course, with the original block here, you can only go up to 14 foot-pounds. Like super, super light. Because even if you have the correct length screws, you can still over torque this and strip the block, because the original block is aluminum. So that is why I recommend every time you rebuild an engine, even if your aluminum block is still good, I recommend buying the steel one. It allows you to torque this a little bit more. You can go to 20 foot-pounds, I guess, or 25 maybe, I don't know. Let me see. That's 26. Anyway, actually I'm gonna put this screw as well temporarily so we can compress the gasket towards the block. And it's the same for the bottom ones, because very often we have leaks from here, from this area, and that's because either the holes are stripped, or even if they're not stripped, we can't apply too much torque. With the steel block, we can do that. 26. Okay, now the camshaft, yes. It's always a question whether it's going to be spinning or not, right? Well, it's spinning, and it has a little bit of end play. Let's measure that. So here the manual tells you to measure the end play with the filler gauge, and the end float, the correct word is end float, is 4 to 8 thou. Well, here in the Rusty Beauties garage, we don't have very good feelings for filler gauges. So we only use them when we can't use a dial gauge. Let's see. Oh yeah, that's exactly 4 thou. I'm not even gonna zero it. So we're going to 30 and 26. 30, 26. So 4 thou, that's perfect. Well, in this case, let's do what we initially came here to do. Oops. I mean, checking the alignment of the camshaft and the crankshaft gears. And don't be like me, this is the wrong way. The TR4 engines, and I believe the Spitfire, you can flip the gears both sides, and that gives you a little bit of a offset of the teeth when it comes to timing. Well, here we can't do that. We only have one way of mounting it, which is this way. So right now it doesn't really matter how we mount it on the camshaft, and we're not even gonna use the tub washer yet. We're just gonna mount it there temporarily so we can check the alignment. Now the crankshaft gear has direction as well, and the direction is with this bevel, chamfer? I can never remember. I think it's chamfer. This is bevel. Is it? I don't know. Anyways, this part needs to go towards the corner here, because this corner here, it's not a perfect square there. So that's why we have this to compensate. So this plane can match with this plane. So let's see. Is it gonna fit nicely? Yes. Oh, that hurts. So now we're gonna take the straight edge and we're gonna check the teeth with these teeth to see how they line. And I actually have a little bit of a gap here. I don't know how well you can see from there, but I am touching here and here, but not here in the middle. Here I have a gap. However, we have to remember that we have end float on both shafts, right? So we're gonna make sure that we measure them in the same direction. So let's push it in, and let's push this one in. So that's crankshaft out, that's crankshaft in right now. Let's see how that's gonna affect us. We still have a gap here. That's interesting. Let's pull this one out. Not touching, let's see. Now I push the crankshaft out as well when the gap becomes bigger. So we are varying between very small gap and a little bit bigger gap. Is it all the way in? Yeah, it is all the way in. So we can't remove material from there. Well, if we put it on the lathe, we can remove a thou or two, but we have to dial it in. And is there point of that? I don't know. So that explains why when we took this gear out, or the old gear out, there were no shims here in the back. And there still shouldn't be shims. Should we put this on the lathe and take a thou away? Let's measure it. What should we say? If it is more than 3 thou, let's say, then we're gonna take the gear out and machine it. But if it is less than 3 thou, we're gonna leave it alone. Well, it's actually pretty big. And that is with the crankshaft in which direction? Okay, let's see what is the best and what is the worst combination here. So with the crankshaft forward, let's push it all the way forward. And the camshaft all the way in. This gap is pretty big. Wow. This is like 10 thou gap. And let's do the other way around. We're gonna push the crankshaft back. So that's the crankshaft all the way back and the camshaft all the way forward. And we still have a gap. Yeah, this is 5 thou gap. So fine, let's remove a little bit, but how much? Let's think. So from here to here, this is pretty much half, right? Let's measure it exactly. From that to here, that's 8, and this is 4. So the amount that we want to close here doubles right here. If we want to reduce this gap by 5 thou, we need to remove 10 thou from the back of this gear, right? It's not going to bring it too close. It's not gonna affect anything here. All right, so I used my 4-jaw chuck and I dialed it in. So there's almost no run out here on this surface. And I also tapped it in, so this surface is now dialed in as well. And now, when I touch my tool, I am at 0 here. Actually, I'm not. I'm gonna have to 0 it. Okay, this gauge is now at 0 when I touch there. So now we can machine it to 10 thou. I'm going to use my power feed, very little at a time. And now our final cut. 10 thou. Whoops, my power feed went the wrong way. That's when you have the same lever for power feed, that's bad. My God. Because this lever is down is for feed that way. I'm used to pushing it down, and this is power feed that way. I went the wrong way. Good thing we didn't cause any damage to the part or the lathe. Wow, that was scary. I usually don't make mistakes like that, but this time I did, and that was scary. So let's just clean up this edge. Okay, push it all the way in. And now we are perfect here, actually. Yeah, I'm more than happy with this now. No shims required. In this case, we can put the woodroof key and put the gear all the way in, and then we can put our adapter on. Wow, that was so close to a disaster. All right, so the woodroof key is installed, the gear is installed all the way in, and we have the adapter installed as well here, which adapter I made out of old sleeve, the sleeve that goes here, so we're gonna have one in this engine as well. That's the sleeve that goes next to the gear, and the front seal rides on this sleeve, right? So from an old engine I kept it, and I welded a big washer and a socket. That's way before I had lathe. We could have done that on the lathe, right? Anyway, and this socket now fits my ratchet, and I can turn the crank. So now we are ready to start installing the pistons and the connecting rods inside. We have them right here. It's all cleaned up, and while cleaning them I was really careful not to mix the caps with the corresponding connecting rod, because they were machined, like they were bored together to the correct size here. So if you mismatch connecting rods with caps, you might end up with an oval or even a step here or whatever. The direction also is important. You can't put them this way. So for the direction, again, you have to match the notch here, but also the shape of the cut here. This is more like a triangle, and this is more like a trapezoid on both sides. So that's how they go. So pistons and connecting rods are ready. We have, by the way, new bolts, because the bolts, these bolts, were super over torqued. Took a lot of force to undo them, which tells me that they might be stretched. So that's why we bought new bolts for here, for the connecting rods. And these are all the old piston rings. Surprisingly, they were all good. I mean, no broken ones. And we have new pistons here. I mean, new rings. They are marked. So we have oil ring. These we're gonna leave for the end. We have first ring, and we have second ring here. And before we install them on the pistons, of course, we're gonna have to check them, check the gap in the cylinders, And here inside, I read before, obviously we have directions here. We have top, where the rings say top, that's the part that goes on top. We're gonna see if they have the same profile here, because sometimes first and second ring have the same profile. But for the first time in a long time, I see a chart like this here, which tells me what the gap needs to be. And here it says that for pistons of a size between 2 and 3/8 and 3 inches, ours are 2 and 94 approximately. So here the gap is 10 thou. For this, what I used to do was I was making a big chart and I was spreading on all the rings and I was marking them 1, 2, 3, 4, 5, 6, and then first and second ring, and I was measuring in the cylinders, marking down. Well, over the years I came up with a much easier way, which is we can put them all in the cylinders and just keep them there. They stay in the cylinder that they fit, and we just take them from the cylinder and put them on the piston when the time comes. How we put them on is first we put the second ring and then the first ring. That's why we're gonna start with ring number 1. We're gonna match them with certain cylinders and we're gonna keep them in the cylinders. We're just gonna push them a little bit lower, and then we're gonna go with the second ring and we're gonna measure those and we're gonna put them on top of the first. And this way, when the time comes to start assembling them on the pistons, we're gonna take the second one first and put it on the piston, and then we're gonna pull out from the cylinder the first ring and we're gonna put it on top. You know what I mean? You get the idea? Okay, so we're gonna leave the number 1 for now there, and let's cut number 2. So let's look at the profile. Okay, now you can see it. So that's the profile. So the chamfered end is our top. That's for second. Okay, let's go to the block now. Yeah, I almost messed up. You're right. We were gonna do number 1 first, right? Okay. Second goes back there. First. No. Yeah. And we're gonna open number 1 as well. Well, it is literally the same profile. Literally the same profile. Well, that's what I see lately, that they're always the same profile. Number 1 and number 2, but doesn't matter. We're gonna be careful. We're not gonna mix them up. So this is the first ring, and I'm just gonna take them and put them all into the cylinders. And I don't remember what the tolerance was according to the manual, but I'm pretty sure it was a little bit bigger. It was about 12 to 19 or something like that for the gap, but it is what it is here. Oops. This one is with the top up. I want to put them in the same direction too, so this is how the top is here, and this is how the top is here. Anyway, we're gonna measure now and see. So top. And now if we have any discrepancy, if we have a too tight gap somewhere and too big on the other side, we might take them and switch them. We're gonna play with them until we are satisfied, and then we're gonna push them down and we're gonna do the other ring on top of this one. So now we're gonna take a piston and we're gonna push them in pretty much to this position. And even though we said earlier that we don't have very good feelings about filler gauges here, well, here we can't do a dial gauge. The only way is with a filler gauge. So let's see. 10 is a little bit too loose. Yeah, 14 is tight. 12 is pretty tight even, but yeah, 12 is good. Here it's a little bit looser. Here 12 is good. Here 12 is good. Here 12 is tight. And here 12 is good. So tight, loose, right? So let's switch these two. Actually, you don't see. Sorry, I didn't zoom you out. So here, number 5, this was tight. And there it was a little bit loose. So I switched the two rings and let's go again. So here 12 was loose. Now it is pretty good. And here 12 was tight. Now it's looser. Okay. So I'm actually really happy with these rings now. Perfect. So we're just gonna keep them there, like I said. We're gonna push them down. So again, this is our ring number 1. Even though for now we're gonna put it on the bottom, this is our ring number 1. And I'm gonna bring our rings number 2. They're all with the top up. Now, if the gap is too big, there's not much that we can do. We have to replace the ring. But if the gap is too small, we can file it a little bit. And I actually had to file only once. It happened to me that I had to file a ring. And to file a ring, you just clamp a file on the vise, and then you grab the ring and you go up and down and you grind it like this. Okay, let's just look visually. Yeah, visually they all look the same. Again, 12. Yeah. That might be a little tight again. No. This time number 6 is a little bit loose and number 2 is tight. So we're gonna switch those. Yeah, that's much better here. And that's much better here. Okay, I am happy with this. So now we can start assembling them on the pistons. We're gonna do that right here. So we're gonna take one oil ring with two rails. Make sure now that we are taking connecting rod number 1. I'm gonna take one rail and we're gonna put it past the channel, past this channel, right? Then we're gonna put our actual ring, oil ring. I'm gonna put it in the channel. Make sure that the two ends meet like that. And now we can push this rail inside to lock the channel, to lock the ring on one side like that. Then we're gonna take the other one. Now we're gonna go somewhere else to make the gap in a different place. It's scraping the oil, so it's good to stagger the two gaps, and that's it. So make sure that it fits inside the channel nicely. Good. Now remember, our second ring here is on top and the first ring is at the bottom, so that was the reason why. Now we're gonna take our second ring, make sure again that the top mark is on top, and we're gonna push it in. Now here they recommend using a tool. I find that a tool is actually more risky. I prefer to put them by hand, so I push one end in and then just slide the other one in, and goes absolutely no problem. And now we're going to pull out number 1 from there. Trying to keep it parallel because otherwise we might scratch the cylinder down there with the end. And again, the top mark is on top and goes straight into the groove, and that's it. Okay, so this piston and connecting rods are ready to go in. We're gonna put the bearings in the last moment. Okay, all the rings are installed. I was really careful about positioning, direction, and all that. I didn't mention why the gap in the cylinder is important. Well, it's very important because if it is too big, obviously you're gonna have a lot of blow-by, and if it is too small, when the rings expand from the heat, the two ends might touch and create tension. And if there's too much tension, obviously the ring can snap. That's why we have to gap them carefully and be precise. So now we're gonna install our bearings in the connecting rods, and we're gonna start dropping them inside the block. We have standard bearings again, standard size, because somehow this crankshaft is not worn. I don't know how for 50 years it remained in such a good shape, and in the meantime the camshaft and the tappets got destroyed. All I think is the wrong oil. But anyway, so here, make sure that there's no debris in the back. The tab goes inside the notch. Same for the other side. And we put them back together so we don't mismatch them. Okay. Pull out the bolts. Just getting ready with everything because later my hands are gonna be really oily and it's gonna be hard to use them. Okay, because I have multiple series on my channel about rebuilding a TR6 engine, and every time I do it the same way. This time we're gonna do it a little bit differently. We're gonna do it more like mass production. So I'm gonna go ahead and I'm gonna prepare everything for assembling, and then we're gonna just assemble everything at the same time. So first of all, the crankshaft is getting all lubricated, then the cylinders, and in the cylinders I put oil, not assembling lube, because I used to put assembly lube, and then somebody commented on one of my videos and said something that makes lots of sense. The assembly lube, when it burns, when you first start the car and it burns, it might burn into something that is not really healthy for the engine. So that's why the cylinders and the pistons, the rings and all that, we're just gonna put engine oil. But the connecting rods themselves and the crankshaft, of course, we're gonna put assembly lube, because the assembly lube is not gonna leak down into the bottom of the engine. Even though I'm planning to start the engine pretty much as soon as we assemble it, but if you're not planning to start your engine soon after it was rebuilt and you use just oil, it's possible that this oil just slowly it seeps through all the gaps and everything, and it just goes to the bottom of the engine. So doing it like this as a mass production, you have to be really careful not to mix up the cups, because I'm gonna do 2 cylinders at a time. So we don't need to flip the engine upside down and then back to the right side up 6 times. We're gonna do it only 3 times, which means that we're gonna have to separate the connecting rods with their cups from 2 connecting rods at the same time, but still keep them in the right order. So what we're gonna do is, let's start with, say, 1st and 6th cylinders, because they're matching, right? So we're gonna separate them. So this is my 6th, this is my 1st here. So split them like this. And now let's go to the block. So we're gonna turn the crankshaft so 1st and 6th are at the bottom dead center. Then we're gonna take our piston and connecting rod number 1 and we're going to put it in the right direction, which means the connecting rod is with the open part towards the busy side of the engine. What I call it the busy side because it has the fuel pump, the distributor, and etc. And also it looks like a C. It doesn't look like a letter that doesn't exist. So a C. Also, the pistons in this case are marked. Some pistons are not marked, but in this case our pistons are marked and they point forward. So that's how it goes. We're gonna drop it carefully into number 1 cylinder, and we're gonna put something through it to hold it up. We're gonna make sure that our rings are staggered now. So I'm gonna put one gap on this side, one on this side. Then we're gonna take our ring compressor and we're gonna tighten it around the rings. This is always tricky because when your hands are oily, it's hard to hold it. Now we can take this out, drop it all the way down. We can tap this gently to make sure that the compressor is aligned with itself. It's not like a funnel and tapered. We're gonna tighten more because I have the feeling that we can tighten a lot more here. I don't know why it's not working. I just broke my spring compressor. Ha ha ha. Okay, whatever. We can tap with something gently at the top of the piston. And it's in. Now I have to figure out how to release the tension here so I can open this. Ah! Well, luckily I have another one which is not very clean though, so I'm gonna go and wash it in the parts washer before I use it. So now we're gonna do the same with number 6. We're gonna make sure that the rings are staggered. The direction of the piston is the correct way. Try to tighten a little bit more. Okay. Let's see. That actually worked. Now we can flip the engine upside down. Number 6. Let's do number 6 first. So we're gonna go up all the way. Okay. We can turn the crankshaft a little bit, but first we're gonna raise number 1 as well. Wow, that's pretty tight. Okay. Now we can turn the crank a little so they can match. And now this is the important moment where we have to match the cups. So number 1 first. This is my number 1. The notch matches the notch here. Two of the new bolts, of course. And then number 6, again, orientation, important. Not to mess it up. We're gonna torque them later. all 6 at the same time, or all 12 bolts. And now hopefully everything is still gonna spin. Yep, nice. So now we're gonna put number 2 and number 5 at the bottom dead center. And these are the ones that we're gonna install next. Alright, you get the idea, right? So I'm gonna put you on a time lapse, or at least on a much faster mode. Right, so they're all installed now. Made sure not to mess up the connecting rod caps. So now we're gonna torque them, and they need to be torqued to 46 foot-pounds. So that's why we're gonna use my smaller wrench. Okay, the main caps are torqued as well. So surprisingly, everything still spins. Okay, cool. So what we're gonna do now is we're gonna put the oil sump on with 2 bolts just to protect it. We still have more work here, so we're gonna come back to it later. I'm gonna flip the engine the right side up. We're gonna take the mandatory shot that we always do. Isn't that satisfying? We're gonna cover it, and we're gonna put an end to this video because I'm pretty sure it is already way too long, and I think it's a good place to take a break. And you need to get ready for the next one because there's going to be a lot of degrees and calculations and all that. We're going to time the camshaft the next time. We're going to degree the camshaft, as some people call it. So we're going to install the degree wheel and dial gauges, etc., from which Chef Tash gets headaches. His brain hurts. Anyway, so that's gonna be in the next one. This one ends here. Thank you guys for watching, commenting, subscribing, sharing, and supporting the channel via PayPal, Patreon, and all other ways. Thank you so much because you are the main reason that this channel continues to exist. Without your financial support, I'm not gonna be able to spend so much time on the computer editing. I would probably make the videos much shorter and not so detailed. I'd probably just film, put the clips together and upload them. But you, with your financial support, are giving me the possibility to be able to afford a little bit more time on the computer instead of here in the garage working on customers' cars. Rusty is anxious to go inside. It's the end of the day. If you're looking for ways to support the channel, you can check the description of the video. There's links to my PayPal, to my Patreon. There's the merchandise store where you can buy coffee mugs, t-shirts and hats and stuff like that. So anyway, it all helps. So thank you guys for watching, and I'll see you in the next one.